Okay, so now we're on to the 12 honors quotes material, AP Calc BC. So we're going to start by getting the derivative of parametric equations, okay? So if you have a smooth curve, some smooth curve, right? X equals some function of t, and y equals some function of t, then the slope of the curve at some point xy, right, is dy dx. But y is a function of t, so that means it's dy dt. X is a function of t, dx dt. Okay, obviously, where dx dt is not 0. Okay, the second derivative. Oh, and just keep in mind what this means, okay? What this is representing is how fast the particle the position, right? How fast the particle is changing. Vertically with respect to the horizontal position, right? All right, so anyway, the second derivative what you're going to get is you're going to get the derivative with respect to t of dy dx, and you're going to divide that by dx dt. Okay, let's look at an example, okay? We have x equals 2 rad t. Y equals 3t squared minus 2t. Okay, we're going to evaluate this at t equals 1. So first, dy dx is going to be dy dt over dx dt. Well, dy dt is 6t minus 2. Dx dt is, you would bring down the 1/2 times 2 and subtract off 1, right? So that would be 1/2 times 2 times t to the negative 1/2. Obviously, these cancel, right? So I can bring that to the numerator. All right, so when I sub in 1, when I find dy dx at t equals 1, I get 4. Okay, so what does this mean? This means that the particle is moving with a velocity of 4 at t equals 1, right? At t equals 1, the particle is moving with a velocity of 4. All right, what that means is up to 4 times faster than to its right, okay? Because it's, remember, changing position vertically with respect to horizontal. So it's going up 4 times faster than to the right. Okay, so let's look at the second derivative. Now, keep in mind that dy dx, right? I'm just going to import it from the previous page, was 6t minus 2 times the square root of t. If I multiply that out, I get 6t to the 3/2 minus 2t to the 1/2. Okay, why am I doing this? Because when I go to get the second derivative with respect to x, I have to first get the derivative of the first derivative, okay, with respect to t. And then I have to divide all that by dx dt. Now, I already have dx dt, if you recall. Dx dt was t to the negative 1/2, so I don't need to repeat that. Okay, so what's the derivative of dy dx with respect to t? That's what I'm doing right here. So I bring down 3/2 times 6, subtract off 1. Bring down 1/2 times 2, subtract off 1. All right, let me clean that up. So that gives me 9. Well, I'm going to divide both of these by t to the negative 1/2. So this 3/2 times 6, that cancels to a 9. I have t to the 1/2 minus negative 1/2. I'm just dividing like this. The heart problem. I'm dividing both of these, okay? Minus negative 1/2 is just going to be 9t. And then when I divide the next part out, I literally end up with 1 minus 1. Okay, so the second derivative with respect to x is 9t minus 1. So the second derivative with respect to x at time at t equals 1 is 8. Okay? So that's like your acceleration, right? So the particle will be accelerating at 8 units. Okay, what do they love to ask you on this topic? Tangent lines. So let's say we have x equals 4 cosine t, y equals 3 sine t. And I want to write the equation of the tangent line at t equals 3 pi over 4. Okay, so number one, you need to get a point, right? So I have x of 3 pi over 4. Substitute that in. That's going to be 4 times cosine of 3 pi over 4. Okay, so think about it. You're in the second quadrant. Here's your pi over 4. Here's your 3 pi over 4. So in the second quadrant, we have all students, right? Take calculus. Cosine is negative. So this is just going to be 4 times negative rad 2 over 2. What does that simplify to? Negative 2 rad 2, right? Then we have y of 3 pi over 4. So that's going to be 3 times sine of 3 pi over 4. But the sine of 3 pi over 4 in the second quadrant sine is positive. So we just have 3 times rad 2 over 2. Okay, so this is your point for your equation of your tangent line. Negative 2 rad 2, comma. And then we have 3 rad 2 over 2. Okay, let's do the slope. So for dy dx, remember we're going to do dy dt over dx dt. Here's my function for y. So when I get the derivative of that, what do I get? I get 3 cosine t. Then I have my x part. Okay, what do I get for the derivative of that? Negative 4 sine t. Now, keep in mind, okay, so let me just make sure I did this right. So I got dy 3 times cosine t. All right. And then I got my dx. Okay, fine. So at any rate, now I'm going to substitute in 3 pi over 4. So dy dx at t equals 3 pi over 4 is going to be 3 times cosine 3 pi over 4, which I told you before is negative rad 2 over 2, divided by negative 4 times sine 3 pi over 4. Now keep in mind that when you're dividing this, okay, so you could see that this part here, I'm going to circle it, that cancels to negative 1, right? So that means the derivative is positive 3/4. Okay, point slope formula. Y minus y1, m, x minus x1. So therefore, the tangent line is going to be y minus 3 rad 2 over 2 equals m times x minus negative rad 2 over 2. Okay, that is the equation of the tangent line. Okay, it's not too bad, but they love to ask that question. Okay, here's another typical question they'll ask you. They'll ask you to find all the points of horizontal and vertical tangency. Okay, and you can graph these things to go check them out, by the way. So here we have our two parametric equations. Okay, so keep in mind when you have 0 over a, where a does not equal to 0, that's a horizontal tangent, right? When you have a over 0, a not equal to 0, that's a vertical tangent. Okay, so we get our dy dx, which we assembled by finding dy dt over dx dt. So when we assemble this, we get 2t minus 3. It's from up here. And then from here, we just get 2t plus 1. All right, so let's take the numerator and set it equal to 0. Let's take the denominator and set it equal to 0. We need to make sure that this value is not in common. Okay, so these are two distinct values, right? So I just take these and I go back to my original equations to get my points. Okay, so remember, points come in the order x, y. Okay, so this is going to be horizontal. This is going to be vertical. So you just sub it in, guys. So you're just going to take your x value. We're going to have 3 halves squared plus t. And then the y value is going to be 3 halves squared minus 3 times 3 halves plus 5. You can just leave it in calculable form. Okay, that's horizontal. And then for the vertical, I'm sure you could figure that out, right? So let's take a look at one more thing for this video. Parametric arc length. This is something else they love to ask on the AP exam. They really enjoy the topic, parametrics. Okay, so the arc length in parametrics from A to B, from t equals A to t equals B, is as follows. And if you recall, we learned arc length earlier on. So, but not in parametrics. So your formula is the integral from A to B of dx dt squared plus dy dt squared dt. Okay, and the reason this works is because of the Pythagorean theorem. Imagine you had these tiny little triangles. Okay, this is what ends up happening. All right, you could certainly Google a proof on that if you want. I'm not going to do that in this video. So let's find the arc length okay, x equals t squared, y equals 4t cubed minus 1 from 0 to 1. So first we get dx dt, right? Okay, dx dt is 2t. You get dy dt, which is 12t squared. Now I'm going to sub this into the formula. Then the rest is just going to turn into integrating. We're going to end up having to do a u sub. So this also gives them an opportunity. I'm just subbing into the formula here, guys, to test you on u sub at the same time, right? All right. So at any rate, we get the integral from 0 to 1, 4t squared plus 144t to the 4th square root. So I need to think about a u sub, all right? So how am I going to do that? Well, I'm going to need an inner function. So if I take out this 4t squared, I end up with 1 plus 36t squared. But when I get the square root of 4t squared, that's just 2t. So now you can see I have a higher power underneath the square root. That allows me to do a u sub. So I let u equal 1 plus 36t squared. du is 72t dt. Therefore, 1 over 36 du is 2t dt. All right, so I have this 1 over 36 is going to replace 2t dt. And then this inner function here is going to be replaced by u. So what does that give us? That gives us 1 over 36. Change the bounds of integration. You can make a little chart. So I had 0 to 1. And then my u value is 1 plus 36t squared. So when I plug in 0, I get 1. When I plug in 1, I get 37. So now my bounds of integration are going to be 1 to 37, u to the half du. Then you don't have to go back to the x. So I get 1 over 36 times u to the 3 halves times 2/3. Put your bar, put your bounds of integration in, and you can leave it in calculable form. Okay, so you'll see that that's equivalent. So that is the length of the arc from 0, all right, to 1. Why do I have an extra mark on my page? Sorry about that. I don't know how I got that there. All right, I took away that extra mark. Okay, so I think that is enough for All right, the first video, and we'll continue this in class. We have one more video for this year, and then the rest is going to be review for the AP exam. All right, guys, see you in class. Thank you. Bye.